No. We just told you the rules.
Oh, my God.
Yeah. I'll be the mic leader for now, you know.
All right, guys, you got this. All right, so are we ready? Sophia, once we're live, you can go to the front side. Welcome to this afternoon session. Sai's going to do it. Yeah. Nice and calm. You stand here always with your knee close to the end of the table. Hello, good afternoon. And so you speak to the lamp in the back behind Mr. Sean's head.
Wiseman.
Yes, Mr. Wiseman. Speak into Mr. Wiseman and beyond Mr. Wiseman. Okay. Are you ready? Okay. Are we on? Guys, are we on?
Good afternoon, everybody. Here I'm introducing you to our lovely cast of speakers, and we'll be talking about space exploration and the governing safe stewardship. So today I'll be introducing you to Dr. Minu Rathnasbapati, who is a senior research engineer and program lead at MIT. And then we also have our lovely ERA students who work at ETH. Wait, that's the wrong way around. They're at ETH and they work for ERAS. Nikolai and Leonie. And then we also have our lovely Rosenberg students here. Yelisei, who's in grade 10, grade 8. And Sophia, Eric, Danielle, Rulin, Dash, Otto, and Asen. Thank you. Let's begin.
Read us the question and the formal title for this afternoon, please.
Right. Okay. Our guiding question for today is, what does responsible innovation require when our systems extend from Earth to orbit, and who is accountable? Okay. Now we can begin. Okay. Yeah. I forgot. I'm starting. Dr. Minu, from your work on shared stewardship, what does shared stewardship mean in practice? Who shares responsibility, and how do we enforce it when incentives conflict?
Yeah, so Sai, thank you so much for the introduction, and thank you to Rosenberg for having me here today. And really happy that we can talk about what I call shared stewardship, a really important topic. Now, my background is in the space industry, and I basically think about how we can use satellite technologies to solve some of Earth's major challenges, that major challenge being, of course, climate. And so listening to the session before was really insightful, and I think it ties well together. So we know that we are really reliant on space technologies in our everyday lives. Everything from GPS to communications. And in fact, over 50% of our essential climate variables can only be measured from space. Only from space. So that means that space and orbits are part of Earth's critical infrastructure. So shared stewardship basically means that we can't be solving the climate crisis here on Earth and then separately be solving the sustainability crisis in space. And in fact, it's one closed loop design system that we need to find answers for both instead of trying to reinvent the wheel in both things. So today we have over 54,000 pieces of debris that are orbiting our planet every single day. 1.7 million pieces of debris, the size of a marble to the size of a tennis ball, and 140 million pieces of debris that are about the size of my fingernail. Now, when you think about how fast these objects are going and the fact that we cannot track these objects, we're basically sending our satellites, these very expensive pieces of infrastructure, into a firing line. And again, we're so reliant on these technologies. So really, we have to come up with these solutions together. So space is a global commons, just as our land is a global commons and our oceans are a global commons. And so shared stewardship is really thinking about how it's not the responsibility of just one country or one nation. It's not the responsibility of just one person. It has to be a collaborative effort. And so I've had the privilege of working both in research, but also supporting the United Nations. And I was just saying to Eric earlier, you know, the UN has what they call the Committee on the Peaceful Uses of Outer Space. And in fact, it is the biggest UN committee with over 104 member state delegations that talk about how can we collaborate together without the geopolitics of the world that's happening in order to continue to keep space peaceful, operational, and usable.
Wow, thank you so much. That was very insightful. It's very kind of interesting new idea to suggest that space isn't just something completely new from the Earth, but also something that we need to kind of talk about and collaborate upon as well. Thank you so much. Moving on to Otto from grade 9, that will be presenting on the topic of interstellar flight. So I have a question for you. When we think about interstellar flight, what stewardship rule should we adopt now so exploration does not become extraction or irreversible harm later?
Yeah, so I think that as we go further into space, we need to make sustainability a central part of every mission because we simply can't afford not to. As Dr. Minu mentioned, how much debris there is already in space and how it's critical that we implement sustainable rules and regulations in space to prevent this from continuing. Yeah, so I think in a way that we could, in a rule that we could implement and adopt to prevent the extraction and irreversible harm later in the future is to build sustainability into every mission from day one. Examples of what we could use here would be a modular system, reusable materials, and we could also try to get rockets back or recover them, as we saw that SpaceX is already doing. And this would really help us to ensure that nothing's left behind and we would prevent the wasted resources in space and just stay more sustainable overall.
Thank you for that. It's very insightful. Now, I have a question for free people, Rulin, Asin, and Dash. If society is a rocket, what are the key components in keeping that rocket afloat? So what's the fuel? What are the different things that you need to keep it running?
Okay, well, I've looked at this in a kind of different ethical way. Well, if you think about a rocket, I would say that every single part and component of it is very important. And so in some way it's similar to society because I think every single person is important and everything should be equal in order for society to work together as a rocket would work well if it had every single component. And so if you look at Earth right now, at the political state of Earth, it's a bit chaotic. And I think if we put it onto the context of Mars, having a really good society would be really important and that everyone is equal because throughout history, I guess, Earth has never been fully equal. There's always been equality, you know, in ancient Greece. Democracies were never actually democracies. You know, you still had slaves who gave their lives away. And if you think about feudalism and the Industrial Revolution, it relied on inequality and it relied on the poor staying poor and desperate and working these laborious jobs. And so I think that's really unfair. And so if we would take it to Mars, I think it is possible for AI, since it's developing so much, that we have AI work these laborious jobs, and so there is no inequality, and so everyone could be educated and in good health, and maybe we could focus more on the development and innovation, and you know overall like could expand cultural aspects of life, and more people I guess could work on hobbies and all those aspects, rather than you know focusing on trying to get a good income. And especially in Mars, because we're foreign in that planet and we're not adapted to it. So we're living in really harsh conditions. So it's not just about like how we're gonna live in a perfect ideal world. It's more about how we need this equal society so that we can survive in this environment.
I kind of interpreted the question as like how the government setup would be on Mars. And I kind of viewed it as like initially it would start off as like mainly research or like mining or industrial. And I thought it could work similar to like research in Antarctica, where no country has a claim to it, and there are treaties and no military, and it doesn't operate as a typical government. It operates more as like a business or a lab. And then as more and more people come to Mars, that they would develop their own rules, because the habitat on Mars is quite different from Earth. So the laws that they make there would have to be like independent of the rules on Earth, and they would have to fit the standards of Mars and the harsh conditions and the limited resources, which would happen when colonies start developing on Mars. And that also, like, no one nation could claim Mars or put any claim on it, and that there would be limits to the environmental things you can do on Mars. As if we plan to build colonies there one day, we don't want the planet to be destroyed, and we want to start from day one, making no mistakes and keeping the planet clean and habitable for everyone. In addition, we want everybody to have equal access to oxygen, water, and protection from radiation. And we don't want people to have to struggle to get basic necessities that they need for life on Mars.
Asun, would you like to add something else?
Although most governments at first won't be agreeing to such conditions, in my opinion, everybody should contribute to this project of colonization of Mars. Even once a colony established on Mars, there are going to be a set of rules that is going to be far more different from those on Earth. So it should be established in a way where everybody can agree, not only in a managed democracy, but in a leadership where everybody can just understand each other in a way. I mean, I don't have much to say.
Thank you so much for all of your guys' answers. That was really interesting and refreshing to listen to. Moving on to the next group of students, which is Yelisei, Daniil, and Eric, that we have right here. So I have a question for you. Rocket recovery is a circulatory challenge. So it's a challenge to kind of have technologies that would be very durable, very efficient, and easy to then later recycle. So what design choice do you think most improves the recovery, reuse, and safety? And what is the biggest barrier to scaling that?
So before we get to designs, I think we should start with problems that we currently face. Well, I believe that we are treating Earth and its orbit as some kind of like landfill, right? And we apply the same single-use logic to space exploration that has already compromised our own planet, which is absolutely unacceptable. Secondly, while we celebrate successful launches, we often overlook the reality. And our gateway to the stars is now becoming more and more cluttered with the most expensive accumulation of debris in human history. Well, to address this, I propose a shift toward a circular architecture, utilizing, for example, magnetohydrodynamic aerobraking to reduce unnecessary emissions? Or what about AI-driven NOAA system for non-destructive hull monitoring? Or thirdly, I can also say about a swarm of drones for re-entry, right? So I'm here to suggest we start building future that is designed to last. Now, Eric, my colleague, what do you have to say?
What about we let Yelisei start? Okay. So here's the thing. Instead of giving something like good ideas like what Daniel has say, and then me and my partner were sitting in the front, and then also everyone here have also participated in a project in which that we actually help in using parachute for rocket recoveries. And then so my one kind of failed, but instead, yeah, my one kind of failed. Yes, but failure is a mother of success. Yeah, so the thing is, so it also kind of succeed in some kinds. And then, well, I can talk about some of the problem why I fail, and then why would maybe I feel like parachute won't be one of the best idea of recycling. So the reason why I fail, the design was too sophisticated, and then so we, and then me and my partner came up with the idea of dual parachuting, and then there was a research paper that I read all through, and it was from MIT. I mean, yes. I love MIT. It's a really nice paper, and then because our technical issues and then it's unmatched with this entire concept, so it falls really bad, and then so there's been a lot of turbulence being created from the dual system, and it crashed on the ground, and so my egg cracked, and then so the thing is, I feel like parachute might be too loosey, and then it's also lack of precision because it's being impacted by a lot of factors: turbulence, wind, everything that could be found inside the atmosphere. And then since we did the experiment inside the ETH room, like inside there was like a big, I forgot to say, a warehouse, right? Yeah, big hangar inside the ETH, and then there's no wind at all, and then yet, based on so many research that I have done, there's still a problem that have existed that I have never expected. Well, that's why I learned from that, and then so I feel like in the future would be something like a precision repulsive catch, like what my physics teacher have this. We discussed in the class. Elon Musk is making these chopsticks, like which they, they catch the rocket. 250 tons of a big thing that came from the sky. It was incredible. The first time I saw this video was when I was still in my home, and then I was shocked. I can't believe like they can actually catch a rocket from the sky. And then I feel like instead, if parachute has so many factors, it might land in the sea waters, it might land in the ocean, and then so it might there's going to be corrosion by the sea waters, and then it's very uneconomical. I feel like maybe the SpaceX progress of how we catch the rocket from the sky might be a better idea because it's more precise. And then yet, I mean, in the future, we are going to colonize Mars. We're going to colonize so many planets all over the solar system, and maybe in the entire galaxy. We need to make sure that we can recycle all these rockets economically, and we can make sure that our future is more recyclable. And then we can, make it land and make it stop like we are stopping a car. Like we're driving the car back to our driving spot, because now we're literally sending Ferraris to the sky, and then I don't know, like how much does a rocket cost? I think a lot, yeah, definitely a lot. We are shooting Ferraris, and then these race cars are all over the sky, and then they just landed in like piece of trash, and then so they go all the way to orbit sometimes, and then we just create more problem overall. And then so the case, I feel like we have to make it precise, we have to make it economical, and then the future is ours, and then we have to make it like as more handle as possible, not something that have been drift all over the wind, and then not something that could go anywhere, like what happened to me. So, I mean, that's what I feel, from stars to moon, and then we need to reuse all these things like cars. Yeah, that's my idea. Thank you.
Okay, thank you, Daniel. Thank you, Eric. So I've also worked on my parachute, and I learned a really valuable lesson that experimenting is everything, failing and redoing, fixing the problems. So what I did is, instead of one big apex vent, I used many, like a material with many vents in it for the parachute. Basically, piece of cardboard with many holes in it, but it worked. So that kind of helped me have more like recyclability in the material. And also, when I was building the project, it kept failing, and I had to do my research. I had to fix the problems, and I think that from experimenting, as I already said, it comes big profit with failure, that you can get something out of it. And yeah.
Thanks, guys, for all of your amazing stories and ideas. So now I have a question for our members at Eris, well, to be specific, Leonie. In a fast-paced rocketing environment, what's the single most important leadership practice that keeps the team from moving fast and safely?
Yeah, I mean, there are many leadership qualities one needs to have to successfully lead a team. But I think the most important quality is understanding your peers, understanding what is important to them, and understanding how you have to communicate as a leader so that they understand you. Because the worst thing that can happen is miscommunication. People not understanding how you intend to say things. Miscommunications are bound to happen. And you have to figure out strategies on how you can work with your team to communicate successfully. Because if you have successful communication, you can talk about all the different aspects of building a rocket, talk about what needs to be improved without it being perceived as criticism, without it being perceived to people as an insult. And I think that's a very, very important quality that is often underlooked, but that is very crucial to being a good leader.
Thank you so much. For sure, all of us need to take that into account. Moving on to Nico. From the engineering side, what's one design or process choice that most improves accountability? For example, in testing, documentation, reviews, and why does it matter as we scale from prototypes to real missions?
Yeah, well, the way we work at ARIS is that we have this whole year project cycle where we have all the process with the design phase. We go through an amount of review to make sure that our system will behave the way it's supposed to. But in the end, I think the one process that really showcases that the system is doing what it's supposed to is the testing phase. So when we really came to the testing and we see, okay, now the system is working, this is the moment where we understand that the choice we did in the design were the right one. For example, I could bring the example of the rocket you can see there. It was the rocket for 2024. And then when we launched it the first time, we had a problem and the parachute didn't open the way it was supposed to. So it came down really fast. We recovered it was still safe. Then we studied what went wrong. So this test helped us in understanding what didn't work. We managed to fix the problem, and then 2 weeks after the first launch, we launched it again, and everything worked then. And then, so really the test showed us what didn't work. And it was really amazing because we have a parachute system that guides itself down to the landing point. And so it landed 6 meters away from our target. So that was coming back to the precision of the parachute. Maybe also parachute system could be precise.
Well, thank you. That's a very nice lesson in productive failure. Coming back to that quite a lot today. And then one last question for Dr. Minu. What is one non-negotiable accountability mechanism you would require for frontier innovation, for example, in space and beyond, before it scales? For example, transparency, safety cases, liability, or something of the sort.
Yeah, great question. And before I answer that question, I would be remiss if I didn't address something else. And it's a term that was used often here, which is the term colonization. And I just want to sort of pause you all and think about how we've used the term colonization here on Earth previously, right? It's not the best term. A lot of people around the world have been colonized, and there's a lot of baggage to that. And we as humanity, as custodians of our planet and our galaxy even, should not feel like we have a right to go and colonize the moon or colonize Mars or terraform Mars. You know, we really have to think about this as, again, as I said, shared stewardship. And my last point on this, I will say, when we talk about, you know, mining on the moon, we also need to recognize there's a lot of cultures and religions across here on Earth that use the moon and the lunar cycle. And so what right do we have ethically, morally, to then destroy these long heritage? So again, I just want you to think about that as you're thinking about the technologies. Because as an engineer, we want to be innovative. We want to go fast and fail fast. Failing is great, right? Failing is good. But we also want to really think about how we do that and what that effect is on other cultures and communities around the world. Now, back to your question. You talk about incentives, and something I think about a lot in my work with space sustainability is thinking about what would be more beneficial? Is it the carrot or the stick? Do we try and incentivize companies and countries to be more sustainable in space? Or do we sort of, wrap them around the knuckles and say, hey, you shouldn't be doing this? And there really isn't one answer that's going to be good or bad. What we do know with the space industry, and it was mentioned here, is that there are a number of new entrants to space, right? If you look at the African continent in particular, Ethiopia recently launched their first satellite, Rwanda, Mauritius, the Maldives. So having these policies and technologies be the stick to these countries, and again, it's very similar to the climate conversations that we're having. It's like, here you are putting these climate expectations on the countries that did not create the climate crisis. So there's a lot of lessons we can learn here on Earth that we then apply to the technologies as well as the policies in space. And I think bringing in an economic aspect as well is really important. So how do we financially incentivize countries and companies to act responsibly in space?
Thank you so much. Once again, very interesting to hear that new perspective, as well as what you said about the word colonizing and the way in which we would be actually experiencing the lives on different planets. That is something really we need to think about. Thank you very much for mentioning that. Dear Mr. Breed, the timekeeper, do we have some time to open the circle?
We absolutely have time for a question or two, so...
Amazing. Okay, let me come by.
Hello, my name is Candela. I just had a general question for anyone who wanted to answer it and have a go at it. So seeing as in our current planet Earth, we have this standard of living in our society, we all have our standard to life. How would you translate that standard when moving into different planets, such as what would be like when we move to Mars? So in terms of comfortability, sustainability, economically, what would be the first to sacrifice, and what would be the one that you follow? I can
maybe start answering that question, but I'd love to hear different perspectives as well. That's a really hard question. I'm not one to sugarcoat my answers. And the reality is right now is that in space, it's first come, first serve, right? So think about who is in our critical orbits, like low Earth orbit. It is the big countries who have a heritage in space. And it's quite frankly billionaires who are sending up 100,000 satellites for communication. So it is first come, first serve. When we think about long-term, living on the moon or even Mars, the likelihood is that that is going to continue, that first come, first serve basis. But that's where policy and places, multinational fora like the United Nations is really critical. So there are space treaties that say that we cannot do harm in space. It has to be for peaceful purposes. But we also need all countries and all space actors to sign on to that. Otherwise, we're just going to be recreating the same problems in space as we have here on Earth.
Thank you so much. Any other questions in the room? Okay. Thank you very much for all of your speeches, and first of all to our speakers, second of all to all of our amazing students. Let's give them a round of applause. And let's move on to the